So already we have discussed about the internal architecture of stepper motor and regarding the 4-step sequence of stepper motor, 8-step sequence of stepper motor. Now we have to discuss about the interfacing of stepper motor with 8051 microcontroller. Now for finding the how we will do the interfacing, there are few things which still we have to understand. And suppose with reference to one stepper motor with an step angle 30 degree, we will discuss now. Step angle is 30 degree. Now let us assume we will use the 4-step sequence. So 4-step sequence is also called as full step sequence. So it is also called as full step sequence, and we will use this sequence A, B, C, D. Sequence will be 1, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0, 1. And in our application we will use the 8-step sequence, 8-step sequence. In case of 8-step sequence, if the step angle of our motor is 30 degree, then with each of these steps it will rotate with 30 degree. But if we will use 8-step sequence, then the angle will become 15 degree. So in 8-step sequence we will use the 8 steps like this. So first we will write same these steps, 4 steps, 1, 1, 0, 0, like this, A, B, C, D. Then 0, 1, 1, 0, and 0, 0, 1, 1, then 1, 0, 0, 1. And to convert it into 8 steps, so I start here with 1, 0, 0, 0, then rotate it 0, 1, 0, 0, rotate this right side 0, 0, 1, 0, then 0, 0, 0, 1. So these are the 8 steps. So these 8 steps we will use in our application now, and if we are using 4 steps, then we will use these 4 steps. Now we will concentrate here on 4 step. If the step angle is 30 degree, then now suppose we have to rotate our motor, one complete rotation we have to make. Now to complete one revolution, in one revolution we know that in one revolution there is 360 degree. Now with one step of 4-step sequence, the motor will rotate 30 degree. So with one step of 4-step sequence, motor rotates 30 degree. So now to complete one revolution, how many steps are required? So here simply a number of steps in one revolution. This is equal to 360 degree divided by 30 degree. So here we will get 12 steps. So if we are having a stepper motor with step angle 30 degree, then to complete one full revolution, we require 12 steps of this 4-step sequence. Because with first step it will rotate 30 degree, then with the second step it will rotate next 30 degree, then next 30 degree, then next 30 degree. Then with these 4-step sequence, the motor will rotate total 120 degree. So in this way, to complete one full revolution, these type of 4-step sequence has to be repeated 3 times. Then one full revolution will be completed. Now, in one full step, in this 4-step sequence, in one 4-step sequence, motor rotates one tooth pitch of the teeth over rotor. So we know that suppose this is the rotor. In the rotor, this is the teeth. Right? These type of teeth are there in the rotor. So from here to here, this point to this point, this is one teeth pitch. To rotate the motor for this one teeth pitch, we require one 4-step sequence. These 4 steps are required. These 1, 2, 3, 4. So 4 steps are required to rotate the motor, and inside the motor there is a rotor. So to rotate one tooth pitch of a rotor, we require 4 steps. So 4 steps required for one tooth pitch of rotor. So now in one step, so for this 4 steps are required for this one tooth pitch. So in one step, how much this rotor will rotate in terms of tooth pitch? So that we can find out. So in one step, so therefore in one step, this is equal to 1 divided by 4 tooth pitch. Rotor will be rotor will rotate, right? So this is one tooth pitch. One tooth pitch will be covered in 4 steps. That's why in one step, 1 by 4 of this tooth pitch will be covered. Now here, total in one revolution, we require 12 steps. So you multiply this by 12. So here Therefore, in 12 step, 1 by 4 into 12, and this is 3, and this will give you the number of teeth on rotor. So for a stepper motor with step angle 30 degree, there will be 3 teeth on the rotor. Now if we are having a stepper motor with 2 degree step angle, then how many teeth will be there on rotor? If we want to calculate this, then we have to follow the same approach. In one revolution, the motor will rotate 360 degree. With one step of 4 step sequence, motor rotates now 2 degree. Because we are talking about this stepper motor will step angle 2. Okay, we will use only one. Now number of steps in one revolution. In one step, motor rotate 2 degree. Then how many steps will be required to complete 360 degree? So it is 360 divided by 2 degree. So we will get 180 steps are required. Now 4 steps required for one tooth pitch of the rotor. So one step will be 1 by 4 tooth pitch. So in now 180 steps. So 1 by 4 multiplied by 180, you find it. So it is 45. So a stepper motor with a step angle 2 degree will have 45 teeth on rotor. So in this way we can calculate the number of teeth. Now when we interface a motor with a microcontroller, then basically suppose if this is a microcontroller 8051 and here we have our stepper motor, right? This is a stepper motor. Now in stepper motor, 1, 2, 3, 4, 5, 6. There may be 6 wires because in last lecture we have just seen that A, B common. C, D common, right? So 1, 2, 3, 4, 5, 6. So in some cases the common wires are joined together and you will get only one common wire, or in some motors you can find 2 common wires. So now suppose we have taken a stepper motor which is having 2 different common wires. So what we will do, common wires are at the center, we will join them together and we will connect it with the rating of the stepper motor. Suppose we have a stepper motor of 5 volt DC which operates at 5 volt DC. Then we will connect with this is common, we will connect it with plus 5 volt DC. Now these pins, now there are 1, 2, 3, 4 pins are there. 4 wires will be there in the stepper motor. These will be connected with the microcontroller. 1, 2, 3, 4 like this. So with microcontroller, suppose we will use port 2. Port 2, pin number 3. Port 2, pin number 2. Port 2, pin number 1. And port 2, pin number 0. Like this we will connect with the port, these wires of the stepper motor. And now to these ports we will give these value sequence 1 1 0 0. So here we will send 1 1 0 0. So in this way we will connect. But now here the problem is in case of 8051 microcontroller, the port pins gives a current, different port will gives the current of different rating. So here port 0, right? Port 0, it gives an output. Output will be in the range of, all the ports will have an output in the range of plus 5 volt. But the current rating for the port 0, all the pins of port 0, it gives 26 milliampere current. And other 3 ports, port 1, port 2, port 3, these 3 ports, they give a current in the range of around 16 milliampere. Now the stepper motor which we are operating here, this stepper motor requires a current in the range of 300 milliampere, 200 milliampere or 500 milliampere, right? So current rating for this stepper motor is more. So how we will directly interface this stepper motor with the microcontroller? Because here the microcontroller pins, they are just generating a current of around 16 milliampere. But the current required to run this stepper motor is in the range of suppose 500 milliampere. Then how we will interface this stepper motor? So for the interfacing of these stepper motors, we require a motor driver. So a motor driver IC ULN 2003A is available in the market. We can use that. This is motor driver IC. This is motor driver IC, and this is 16 pin IC, and the current rating of this IC is 500 milliampere. It generates this current. The rating, it is the 500 milliampere current output. This IC generates 500 milliampere current, and the output voltage can be of 30 volt. So here if we are having a stepper motor which operates at 30 volt, then we can connect 30 volt DC to this, right? So we will use ULN 2003A part number IC, and in this IC the internal structure of this IC is somewhat like this. It has basically 7 channels. 7 channels means this is input number 1, and corresponding to this you will get one output number 1, and internally This is Darlington pair NPN transistor. Darlington pair NPN transistor is used in Satish, pen there. So is used. So Darlington pair NPN transistor amplifies the current. So here, if at the input, if we give a 16 milliampere current, then it amplifies it to 500 milliampere current. You will get at the output, and these output we will connect with stepper motor. So this is input number 1. Input 2, out 2, out 3, in 3, out 4, in 4, out 5, in 6, out 6, in 7, out 7. So these are the 7 channels. So there are 7 Darlington pair NPN transistors. Now there is a pin for ground. So this is for ground, and there is a pin for common. One output pin for common. And internally, apart from these Darlington pair structure, there is a diode also, right? And this diode is Flyback Diode. So it is always connected in reverse bias condition, and due to this it is possible to connect an inductive load to the microcontroller. Because when we are using an inductive load, then when we are starting that motor, right, or inductive load, when we are switching the inductive load from on to off position or off to on position, a high current is generated, and that current can enter in your microcontroller pins and it will damage the port of the microcontroller. So to prevent the damage to the port pins, we use flyback diodes. So since this diode is in reverse bias condition, so it will not allow a high current which will be generated while switching off inductive load to enter inside the controller pin. So there are 7 flyback diodes. So the anode terminal, this is the anode terminal and this is the cathode terminal of the diode. Anode terminal is connected here. Output of this buffer. And the cathode terminal of all the diodes are joined together this, 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 and it will be taken out as a common terminal. So this flyback diode is connected inside as common cathode, diode. Now if at this common terminal, if suppose here we connect plus 5 volt to this common terminal, now what will happen? All the cathodes of the diode are at plus 5 volt. So if this buffer generates here 0, binary 0 means 0 volt. So here you are having binary 1, that is plus 5 volt, and here 0 volt. So this is ground and this is plus 5 volt. This diode is reverse bias condition. And if this buffer is generating binary 1 means it is plus 5 volt. So plus 5 volt is connected to anode, and cathode is also connected to plus 5 volt. So now both anode and cathode are at same potential. So again this diode will not conduct. So whether this buffer is generating binary 0 or binary 1, under both conditions these flyback diodes will be in reverse bias condition. It will always off. So in this way it will protect the reverse current, right? So now this ULN2003A is a 16 pin IC. So we will find out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is a 16 pin IC. So this IC will be used to interface your stepper motor with your microcontroller. So I will draw a smaller diagram so that I can write the code also. I will draw here. So this is our microcontroller. Now we will take, this is ULN2003A. This is microcontroller 8051. And here we are having a stepper motor. This is a stepper motor. One, two, three, 4, 5, 6. So first thing what we will do, we will take these common wires, right, and the output, the common output, this is common pin of the ULN is joined together here, and this we will connect to plus 5 volt DC. Now this is out number 1, out number 2. Okay. Out number 3 and out number 4. Output of the 4 outputs of the ULN 203. And here we have in number 1, in number 2, in number 3 and in number 4. So out of 7 channels of ULN 203, we are using 4 channels. And these we are connected to the microcontroller. Suppose this is P 2.0, P 2.1, P 2.2 and P 2.3. So in this way we will interface. Now we will take one example. Now suppose we are having a stepper motor with step angle 30 degree. So now we have to rotate the motor for 120 degree. Means we want to give one full step sequence. So with this, rotate 120 degree. And for this we will use one full step sequence. Right? This one sequence we use. So we will write the program for this. Program will start from org 0000H. So now we have to send this value to this port. In port 3, we know that there are 8 pins. 8 pins are P2.7, P2.6, P2.5, P2.4, P2.3, P2.2, P2.1 and P2.0. So first step in the 4-step sequence is 1100. So we will give at 1100 to pin number 2.3 to 2.0, because 2.3 to 2.0 are connected to the stepper motor, and the remaining pin of the ports we are not using. So if you are not using, then you can send either 0 or 1, it does not matter. But general practice is, if we are not using any pin, we send 0. Right? So pin number 2.7 to 2.4, we will send 0, 0, 0, 0. This will be our first sequence. Right? So I will write the program here. Move P2, hash 0, 0, 0, 0, 1, 1, 0, 0 in binary. Now once I will send this sequence, motor will rotate 30 degree. Now I want that next 30 degree motor should rotate after some delay. Right? After some delay, rotation should be like this. 30 degree and 30 degree, 30 degree means after some delay. So after sending this value, I will write an instruction L call delay. I will send the sequence of my program to a subroutine where I have written the instructions to generate delay. So somewhere else I will write, here I will write delay. Suppose from org 0050H delay. So here we have written some instructions to generate delay, and in the last there is return instruction. So with the return instruction, program will come back to the main program. Now we have to send the second step of full step sequence. So now move P2, hash 0, 0, 0, 0, these are higher 4 bits, then 0, 1, 1, 0. This is the next sequence, 0, 1, 1, 0, 0, 1, 1, 0. Again after sending this sequence, immediately motor will rotate another 30 degree. So by now motor has been rotated 60 degree. And then again we have to wait for some time. So again I will send the program to delay. I'll call delay. Program will again go to this delay subroutine. It will execute some instructions for the delay. Again with the return, it will come back to the main program. Now we have to send the third sequence, right? Third one, so that motor should rotate another 30 degree. So here I will write move P2 comma hash 0 0 0 0, then sequence is 0 0 1 1 B. This one 0 0 1 1. After this again I'll call delay, then fourth sequence move P2 comma hash 0 0 0 0, and then 1 0 0 1 B. 1 0 0 1 is the fourth sequence. 1 0 0 1. Now motor, with this motor will complete 120 degree, and since we have to rotate it with 120 degree only, then we will stop the program. Yeah, after this you send the program to the delay routine. That is important. Call delay, then stop the program. So S jump here. That's all. So with this set of instruction, motor will rotate 120 degree. Now in our application, suppose we want to rotate a motor one complete revolution. 120 degree, 360 degree rotation we require. Motor should rotate one complete revolution. Then we know that, and we will use same 4-step sequence, this full step sequence. So now in this case, in one full step sequence, motor rotates 120 degree. So to rotate 360 degree, we require 3/4 step sequence. So this one sequence will rotate the motor 120 degree. Then this type, if we will give 3 sequences, then motor will complete one full revolution. For this, what we will do, we will use one register to count that whether we have completed all the 3 4-step sequence or not. So for this, I will use one register here in the beginning. Move R0, 03H. Since we require full step sequence, this type of 3 sequences, that's why we have loaded a value 3 in R0 register. After this, these set of instructions will be executed. So these set of instructions will give one full step sequence, right? So after this, before stopping our program, we will here reduce the value of R0 by 1 with the instruction D, J and Z R0. If R0 is not 0, then repeat the sequence. So then repeat should come here. So now here, if value of R0 is 3, so with this instruction D, J and Z, R0 will become 2. Since it is not 0, come back. Send the first step of 4-step sequence. Then second step of 4-step sequence. Third step of 4-step sequence. And fourth step. So with all these 4 steps, again motor will complete another 120 degree. So now total 240 degree rotation has been completed. Now D, J and Z will again reduce the value of R0 by 2. So previously it was 2, now it will become 1. Still it is not 0, we will go back to repeat. Now first sequence of full step sequence, second step of full step sequence, third step of full step sequence and fourth step of full step sequence. So now again these 4 steps will again rotate the motor 120 degree. 240 degree already motor rotated. Now this set will give another 120 degree. So now 360 degree has been completed. So now we have to stop. So by this, now this instruction will be executed and R0 will be decreased. So previously R0 was 1, now it will reduce by 1 and it will become 0. Now once it is 0, program will not go to the label repeat, it will come out from the loop. And now you can stop the program. So S jump here. So now these set of instructions will rotate the motor 1 full revolution and the step angle of the motor is 30 degree. Now suppose we are having another application, and in that application we want to rotate the motor by 100 or 270 degree. Suppose we are developing some robot arm and the application is robot will pick one object and it has to be moved up by 270 degree. So that precise movement is required. So here we are having same motor with the step angle 30 degree. So how we will rotate it to get 270 degree? We know that one full step means 4-step sequence. So one full step sequence rotates the motor. One full step sequence means all of these sequence is called one full step sequence. It rotates the motor by 120 degree. Now 2 full step sequence will rotate the motor by another 120 means 240 degree. So 2 full step sequence are required to rotate the motor by 240 degree. But we require another 30 degree. Right? We require another 30 degree rotation. So by this, one full step sequence is completed, then second full step sequence is completed, motor rotated 240 degree. Again what we will do after this, we will send this sequence only one sequence, because we know that with each sequence motor rotates 30 degree and sequence should follow a specific pattern. After this we have to send this only, right? So this will give another 30 degree rotation. So for this what we will do, first we have to rotate the motor 240 degree. For this 2 4-step sequence are required. So now in R0 register, in place of 3 we will load the value 2. Now once the value of R0 will become 0, by that time motor will complete the rotation of 240 degree. 2 full step sequence will be completed. Then program will come out from the loop, right? So now controller will be here to execute some instruction. So when we are here, we have completed 240 degree rotation. Now we require this sequence only. So now here I will write the instruction: move P2, hash 0000 and 1100B. So now this sequence, this step will go to port 2 and motor will, with this will rotate another 30 degrees. So now it will become total 270 degree. So after this again we will go to the call subroutine, delay, L call, and then we will stop the program. S jump here. So now this will rotate the motor by 270 degree. Now we will see another example. We are having same motor with step angle 30 degree. Now we will use 8-step sequence. 8-step sequence is also called as half-step sequence. So we will use, in place of full step, we will use half-step sequence. Now in case of half-step sequence, the step angle will become 30 degree, will become half, that is 15 degree, right? So if we will give one half-step sequence, full this half-step sequence, all the 8 steps, then motor will rotate 15 degree multiplied by 8 will equal to 120 degree, right? So simply in this application we want to rotate a motor to 120 degree with improved resolution, because now resolution is better. Previously in one step it was moving 30 degree, now 15 degree only. So resolution is better. So now here we will remove this instruction move, right? And we will write this sequence. Move P2 comma hash 0000100 B. This is the first sequence 1000 B. Then I'll call delay. Then move P2 comma hash 0001100 B. This one. Then I'll call delay. Then move P2 comma hash 0000100 B. Third, this one 0100. Then I'll call delay. Then move P2 comma hash 0000 and 0110 B. After 0100, 0100, 011 B, 011 B. Okay, this is done. Then I'll call delay. Move P2 comma hash, this we will rotate 0000 0010 B. This one 0010. After this 0011. Then I'll call delay. Move P2 comma hash 0000 011 B. Then I'll call delay. After this move P2 comma hash, this one will be shifted here 0000 B. This one I'll call delay. After this last move P2 comma hash, this one 0000101 B, right? And here then again I'll call delay and S jump here. So now with this motor will rotate 15 degree, with this step 15 degree, with this 15 degree, with this 15 degree, 15 degree, with this step 15 degree, this 15 degree, and with this 15 degree. Yes, 1, 2, 3, 4, 5, 6, 7, 8. 8 into 15, 120 degree. Now suppose another case, we have same motor with step angle 30 degree, and want to rotate the motor, with 255. Okay, with 255 degree. Okay, the step angle is 30 degree, and we want to rotate it 255 degree. So in this case, if we will use 4-step sequence, then what will happen? With 2 4-step sequences, we will rotate the motor by one 4-step sequence will rotate 120, another will rotate another 120, so we will get 240 degree, right? Now we have to rotate another 15 degree. But if we will give another this sequence, then motor will rotate 30. From 240 it will go to 270 degree. It will not stop at 255 degree. So now what to do? Now option for you is you go and purchase another motor with a step angle of 15 degree. Then you can rotate it. But we don't want to change the hardware. With the same motor we want to rotate it with 255 degree. So now it is possible with 8-step sequence. Because with first 8 step, it will rotate 120 degree with the resolution of 15 degree with each step. With the another second 8-step sequence, it will rotate another 120 degree. So now 240 degree is completed. Now after this, I will send only this step, single step. So this step will rotate the motor with another 15 degree. So now 255 degree will be achieved. So in this way we can do this. So for this what we will do, we will use here again one register, move R0, hash. In that we will load the value 2, because these 8-step sequence we have to give 2 times to get 240 degree. And in the last, in place of S jump, here we will write D, J, N, Z, R0, repeat. Okay, and repeat is here. So with this set of instruction, R0 will become 0 after running this loop 2 times. So when we will come out from the loop, so by that time motor completed 240 degree. Now another 15 degree is required. So simply we send only this sequence. So here we will write move P2, hash 0 0 0 0 1 0 0 0 B. And after this I'll call delay, then S jump here. So in this way we can achieve 255 degree. So in this way we have just written few example code. Now in next lecture I will just demonstrate you this time software called as Proteus. Right? In Proteus we will interface this stepper motor and we will write these codes and we will see the performance. So that in the next lecture.